Recently, Amazon S3 has introduced a third type of bucket called table buckets. This purpose-built storage is optimized for analytics workloads. Similar to S3, you can easily create table bucket using AWS Management Console or AWS CLI. But to create, modify, and delete tables, you need to use Amazon EMR or Elastic MapReduce. Amazon EMR cluster creation is not straightforward and it costs money too. If you just want to avoid all these for your hands-on, then you must watch this video. In this video, I'll show you how to create table, insert data, and query that table from your local. For this demo, I am using Ubuntu operating system, and from AWS CLI changelog, we can see CLI version 2.22.10 has introduced these S3 tables. So let's check the AWS CLI version and make sure it is more than 2.22.10. We will run Apache Spark Docker container and we will use Docker official image. So make sure Docker is installed in your local. If you have not created any table bucket yet, let's create table bucket. Provide a table bucket name. This has to be unique within this account for this region. If you want to access your table buckets from AWS query engine like Athena, Redshift, EMR table, then make sure this integration is enabled. This will basically create one service role and which will allow AWS Lake Formation to access all table buckets and register all those table buckets in this region. It will also create a catalog named S3 table catalog under AWS Glue catalog. And also it will create subcatalogs within it for each table bucket in that region. Let's quickly check how it looks like. So in S3 tables, we will create table bucket. Within bucket, we will create namespace. And under namespace, we will create multiple S3 tables. Namespace are basically logical grouping of S3 tables. So here table is like glue data catalog, namespace is database, and table are glue table under that database. Click create table bucket. Table bucket creation is successful. Finally, we need one IAM user who has necessary access for Amazon S3 tables. For AWS CLI access, we need access key. If you don't have, create one. Copy access key and secret access key and keep it handy. I have already created one file called AWS create and copied access key ID, access key and region, and I'll pass this file as environment variable to Docker container. By the way, I have shared all the details and code in my blog awsjunkie.com. If you want, you can check it there as well. Let's go to user guide. To initialize Spark session, you need Iceberg Spark runtime and S3 tables catalog for Iceberg runtime. You also need some dependencies from AWS SDK. So instead of finding those manually, I went ahead and checked the GitHub for S3 tables catalog. Here I can see two Gradle dependencies. When I checked Maven repository for S3 tables, I can see 3 compile time dependency, and for S3 tables catalog, I can see many runtime dependencies. So I'll create a empty Gradle project and use these dependencies. This is where I initiated my Gradle project. This is the Gradle project structure, and in the build Gradle file, I included those dependencies. Then I ran Gradle build task. And this pulled all the dependencies, including transitive dependencies. I copied all and pasted in a separate folder called extlib. In the generated script file, I can see all the jars are listed here. So I'll do some string manipulation here to replace app home lib with extlib. I created this comma separated list of jars and I will set that to dependencies environment variable, which I will pass to Spark container. Let's set the comma separated list of jars to dependencies environment variable. I'll run this Docker command, but let me explain it. So we are going to run this Docker container in interactive mode. And Spark is the image that will be pulled from GitHub, and we'll launch Spark shell. If you want to launch PySpark, then use PySpark instead of Spark minus shell. Here we are going to mount local extlib directory to extlib volume. And this is the directory which contains all the dependencies which will be used by Spark. We'll pass AWS access key ID and secret access key through this environment file. And we'll pass all the comma separated list of dependencies using this dependencies environment variable. And finally, all the configuration. If you go to user guide, you will find all the configuration that is required. Here, catalog is Spark catalog. Catalog implementation is S3 tables catalog. And warehouse is ARN of your table bucket. One thing note here, I have used AWS Junkie as catalog name. So I have to keep that name in all the configuration. Hit enter. Spark shell is launched. So in user guide, you will find all the command to create namespace, create table, query table, insert data into table. I have referred all those from that user guide only. Create namespace, catalog name dot namespace. So this catalog name which we provided through configuration here. Then namespace name test.ns. Hit enter. Namespace is created. Now let's create an Iceberg table under AWS Junkie.test namespace. Table name is demo underscore table. And this is the structure of this Iceberg table. Hit enter. Table is created. Now let's make a query to that table. Right now it is empty. And as expected, there is nothing in that table. Now let's insert some record into that table. Insert into demo table. Then provide some records following the structure of the table. And it is successful. Now let's make a query again. And we can see two records which we inserted earlier. Let's go back to S3 console. Click the table bucket. We can see the created demo table. And we can get the table bucket details using AWS CLI and SDK. And we can also use Athena query editor as we enable that integration. Let's go back to console and try some AWS CLI commands. Type AWS S3 tables help. And you will find all the available comments here. List table buckets will give you list of all the table buckets. List namespace, table bucket ARN will give all the namespace under that table bucket. List tables, table bucket ARN will give you all the tables under that bucket. Name demo table, type customer. Click info, you can see there can be two types of tables, customer minus table. These are the tables that you can read and write. And S3 managed tables which are read-only managed by AWS services. That's why you are seeing type customer for your table. Last important point, to enhance the performance of S3 tables and table bucket, S3 does file compaction, snapshot management, and unreferenced file removal by default. And you can edit or disable this configuration through maintenance configuration files. Let's click S3 table maintenance job status. To get this status, you can run this command. Get table maintenance job status, then table bucket ARN, namespace, and the table name. Here you can see Iceberg compaction job status is successful, snapshot management is successful, unreferenced file removal not yet run. If you want to update table bucket maintenance operations, then you can do so using put table bucket maintenance configuration. And similarly for table maintenance, you can use put table maintenance configuration. That's it for today's update. Thanks for watching. Hope to see you in the next one. Until then, happily float on the cloud.